Hello, you are most welcome. I'm teacher Ivan, welcoming you to our next lesson. We are still looking at matrices, and in today's lesson we are going to look at basically the identity matrix for multiplication. We saw this in types of matrices where we say that an identity matrix is a square matrix whose elements in the major diagonal are ones and it has zeros elsewhere. And this is what we mean by the identity matrix. This is a 2 by 2 identity matrix where it has 1 1 in its major diagonal and the zeros elsewhere. This is a 3 by 3 identity matrix where it has 1 1 1 in the major diagonal and it has zeros elsewhere. So these are what we call identity matrices, and they are always denoted as capital I. So whenever you see capital I in a matrix, that means an identity matrix. One, it should be a square matrix whose number of rows is equal to the number of columns. So the identity property of a matrix multiplication is such that for any square matrix A times the identity matrix equals identity matrix times A. So remember, when starting the multiplication in the previous lesson, we saw that when I'm multiplying matrices, let's say P and Q, we proved that PQ is not equal to QP. But for an identity matrix, AI equals to IA, this is what we call the multiplication property of an identity matrix, because it only holds for an identity matrix. We have examples concerning the identity matrix where we are given that matrix A equals to this, and this is matrix B. So they want us to find AI and IA, IB and BI, where I is a 2 by 2 matrix. Remember, if this is a 2 by 2 matrix, then that means that even our identity matrix should be a 2 by 2 matrix. Let us try getting this. We have AI. Remember, this is the same as A times I. So A is 2, 4, 3, 1 times I, which is now 1, 0, 0, 1. So we multiply row by column. That is 2 times 1, which is a 2, plus 4 times 0, 0. Then 2 times 0, 0, 4 times 1 is a 4. Then we also multiply the lower row, that is 3 times 1 is 3, plus 1 times 0 is 0. Then the second column, 3 times 0 is 0, plus 1 times 1 is 1. So from there, we are going to add. That is 2, 3, 4, 1. And now let us also find IA. So IA, similarly, we shall start with I, which is 1, 0, sorry, this is 1, 0, 0, 1, times A, which is 2, 4, 3, 1. So when we try to multiply row by column, this is 1 times 2, giving us a 2, plus 0 times 3, 0. Then 1 times 4 is a 4, plus 0 times 1 is a 0. We come down, this is 0 times 2, which is 0, plus 1 times 3, 3. Then 0 times 4 is 0 plus 1 times 1, which is a 1. So we shall end up with a 2, 3, 4, 1. So you see that the IA, which is given by this, is equivalent to AI, which is given by this. So these ones are the same. That means that the condition for the identity matrix multiplication property, which says that AI must be equal to IA, has been satisfied. And therefore, I want you to try out part B, whereby we are going to get IB and BI, and also confirm whether they are equal. Otherwise, let us continue. Next is what we call a singular matrix. A singular matrix is a matrix whose determinant is equal to 0. And now when we talk about determinant of a matrix, what do we mean by determinant of a matrix? The determinant of a matrix is denoted as det. Let's say a matrix A, its determinant is det A, or we use that. And now, considering matrix A, which is given as A, B, C, D, then the determinant of matrix A is given by the product of elements in the major diagonal, that is A times D, take away the product of elements in the minor diagonal, that is B times C. And that gives us AD minus BC. This is how we get determinant of a singular matrix, of a matrix. Now, for a singular matrix, for a matrix to be singular, its determinant equals to 0. For a matrix to be called singular, its determinant should equal to 0. Meaning that if A is a singular matrix, then this determinant was equal to 0. That's what we call a singular matrix. So, for instance, we have an example where for a matrix A, which equals to ABCD to be singular, then the determinant of A equals to 0. That is to say, AD, we saw how we get determinant. We multiply the elements in the major diagonal, that is A times D, take away the product of elements in the minor diagonal, that is B times C. And that means that AD minus BC must be equal to 0 for a singular matrix. And now, let us look at how we can apply this knowledge in answering questions. In question 1, we are told to show that matrix 2, 8, 1, 4 is a singular matrix. But remember, for this matrix to be singular, its determinant should be equal to 0. So, in showing that it is singular, we show that by finding its determinant. And if the determinant equals to 0, then it will be a singular matrix. So determinant is given by the product of elements in the major diagonal, that is 2 times 4, take away the product of elements in the minor diagonal, that is 1 times 8. And indeed that gives us 8 minus 8, which is 0. So meaning that this matrix is singular since its determinant is 0. Let us continue. We have another question which says that given that matrix A and matrix B, then if AB is a singular matrix, they want us to find the value of A. So, meaning that to first get AB by multiplying. After getting AB, we get the determinant of the result and equate to 0 for us to get the value of A. This is what we mean. We are told that AB is a singular matrix, meaning the determinant of AB equals to 0. So for us to get the determinant, we first get AB. So AB is gotten by multiplying. That is the matrix A, which is 1, 0, 2, 2, multiply it by A, 2, 3, 5. Remember, we multiply row by column. After multiplying, we shall get a determinant and equate to 0 for us to get matrix C, to get the value of A. So you are going to complete that. Otherwise, that's all about the singular matrices. Next is how we get determinant and probably inverse of a matrix. So this will be for our next lesson, so please don't miss out. We are going to look at how we get determinant and the inverse of a matrix in our next lesson. Otherwise, I'm teacher Ivan from Wuuna Educational Services. Please, I urge you to join our other platforms. We have Facebook pages and groups. We have TikTok accounts. We are on Instagram. We are on Twitter or X. We are on other social media platforms. Just search for Wuuna Educational Services. Join us and we walk through your academic journey together. Otherwise, I hope to get you next time. Bye-bye.